What's that? It's Wednesday. Time for the Bellringer. Your favorite time of the day. Sometimes. A few times. Maybe. No, probably never. Really. I understand. Yeah, but we're going to do the Bellringer. I'm not here today, but I got a whole slate of things for you to do. In class, we're going to learn about taxonomical hierarchy and the levels of classification. Remember, King Philip called out for greasy spaghetti. If you remember that, it'll help you. And then what else are we going to do today? Maybe talk a little beaks and finches. Maybe, just maybe, we'll do a little something else. But all right, let's focus, get to work, get our stuff done that we need to do today. All right. Hey now. Mr. Kovacs class. It's Mr. Kovacs class. You might learn on time. It's Mr. Kovacs class.
He's interested too.
It's Mr. Kovacs class.
And he's super cool.
It's Mr. Kovacs class. Have learned that all species on Earth are given a two-part scientific name. The first part is called the genus. Second part is called the specific epithet. Species. Genus, species. They go together. Can't really have one without the other. So when you're describing an animal or a plant or whatever by its scientific name, you give both the genus and its species name. It's kind of like going last name, comma, first name. All right? A couple of rules or conventions that you need to know. The genus is always capitalized. Always capitalized. Is it capitalized? Yes, always. But the species name is never capitalized. No, never. Do not capitalize the species name. Genus, species. Capital, no capital. And then the other thing that's a convention that you need to know is that whenever you write out a scientific name of an organism, you need to put it in italics, right? Or it's also okay to underline, but we prefer italics. All right, so scientific name, genus and species. There are other levels of classification too. We call this the taxonomic hierarchy, and we use 8 levels to classify every organism. Genus and species is the last bit of the classification. But we classify organisms based into various groupings, groups that they belong to based on traits that they have. And we start with the most general, and we move down to the most specific. In the case of taxonomic hierarchy, the most general is what's called the domain. There are 3 domains. All living things fit into one of 3 big, broad categories. Then within the domains, there are kingdoms. All organisms fit within a domain, and then within that domain, they fit into one of the kingdoms. And then among each kingdom, there's what's called a phylum. So an organism fits into a domain, a kingdom, and a phylum. In a phylum, there are a bunch of subclasses. And in each class, there's orders. And in each orders, there's families. In each family, there's genera or genuses. And in each genus, there's species. Hierarchy. Levels of organization. Here's an example. Ursus arctos, the grizzly bear. Right? Ursus arctos, the grizzly bear. Well, if we could look back at Ursus arctos, he is the grizzly bear, or she. They come in both, right? There are other bears out there. There are Ursuses, right? And then there are other bear-like things out there called Ursidae. And then there are other things out there that have the specific kind of cutting teeth, the carnivora. And then there are other things out there that are also mammals, right, to give birth to live young and those kinds of things, nurse with milk. And then there are lots of other things that have nervous systems through a spinal cord, the chordates. And then, of course, multicellular eukaryotic consumers are what we call animals. So if you look at it, the kingdom is the broadest. It's got the most things in it, right? It's got sea stars and snakes. When you move to the chordates, you eliminate sea stars because they don't have nervous systems and cords and spinal cords. When you move out of chordata, you lose the snakes because the snakes are in a different phylum, I'm sorry, when you move out of phylum into class, snakes are in a different class. They're in a class of reptiles, not in the class of mammals. When you move out of the class of mammals into the order Carnivora, you lose the squirrels, because squirrels are in a different order. They're in an order of rodents, right? When you move out of the order Carnivora into the family of Ursidae, you lose the foxes, because the foxes are in a different family. They're in a family of canids. And you move out of the Ursidae family into the genus Ursus, you lose panda bears because they're in a group of cat-footed bears, Melanoleuca aleoropida. And then, of course, of all of the different bears, Ursus arctos is the grizzly bear. Right? So kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species. Kingdom, phylum, class, order, family, genus, species. Let's recap a little bit of what happened on the islands of the Galapagos with our finches and their various beaks. If you recall, your finch had a beak, and its beak fed on seeds of various varieties, small seeds, large seeds. The yummy seed. Okay. So in the Beaks of Finches lab, you did 3 rounds, 2 trials in each round. So you should have fed 6 times. First time was on your island with no competition, just you feeding. The second round should have been you with some competition with other beaks from other islands. And then the third and final round was all of the surviving. So there were like a dozen different birds feeding. Okay, so we got some results from that. I'm going to share the results with you now. Into a spreadsheet. This is using data from a couple years ago. I decided for this year, since I had this data, we'll just use this and let you play the game without having to worry about taking meticulous, detailed data. But basically, you had 2 islands. You've got the islands of small seeds and the island of big seeds, and we have 5 different beaks, right? And they got to feed with competition and without competition. Let's see what happened. And then I've added this into your Google Classroom, into the assignment, so that you can use this data to do the lab. But I give basically for each beak type how they did with no competition, then with competition, then with heavy competition. What we found is that pretty much every beak size on every island, as competition increased, how well you did decreased. Okay, and of course the magic number was 13, right? So you can see that there's some organisms that would have survived if there was no competition, but once there's competition, they can't survive. They can't compete with their neighbors. All right, so we're going to finish up the Beaks of Finches lab, our next lab period. If you have lab today, you're watching a video. If you don't have lab today, you're not, because you don't have lab today. All right, let's do the Bellringer. Let's learn about taxonomy, and let's go.